Okay, in this presentation we are going to look at survival functions which come up in reliability analysis. Okay, so this is a very straightforward one. I've done some sort of previous sort of examples, so I'm just going to sort of highlight the main points here without getting bogged down by any of details to any great extent. The survival function for the distribution of a lifetime of an electronic device is, this is S of x, that's the survival function. The x means the lifetimes, okay? So capital X is the lifetime. Equals to 1 over 40 times e to the minus x over 10 plus 1 over 20 times e to the minus x over 15 for x greater than 0. Calculate the mean and variance of such lifetime. So what we're expected to do is, now here, this is just a formula sheet, and hopefully you'll have something like that available to you. Now this is the key one here, okay? The kth moment of t, the expected value of t to the power of k. This is the integral from 0 to infinity of k times t to the power of k minus 1 times s of t, the survival function, dt. Okay? Now, in the case of the mean, the expected value, k is equal to 1, so that just simplifies to 1. In the case of the second expected value of t squared, k is equal to 2. So k times t to the power of 2 minus 1 just simplifies to 2t. Okay, so that's the sort of the key materials there, the raw materials for what we're going to be doing here. Now, just as a quick remark, particularly the case of exponentials, which will come up in a lot of the sort of more introductory examples relating to reliability analysis and survival functions and so on, we will have integrals of functions that are essentially exponentials, e to the x, e to the power of ax, and so on. So essentially what I'm saying here is that you have to really be very quick with these sort of things, okay? You can almost just sort of take them, present them as given, okay, but just be very sharp with them, particularly the last one there, which will pop up quite a lot in questions like that, this one, because they always seem to take this sort of format here, okay, e to the minus x over 15, partly because, you know, that's the only sort of essentially the format that does make sense for these sort of questions. They don't, if it was e to the plus x over 15, it wouldn't make any sense. It'd be just crazy. Anyway, so that one in particular, usually you can sort of state it as is, okay? Because you're expected to know integration and the fundamentals of integration. So, by the way, k there is just the coefficient of integration, okay? So 1 over c to the power of 1 over c times e to the minus x over c. When you integrate that, you get minus e to the minus x over c, okay? Now, so the expected value of t, okay? Well, actually, I've noted it as x. The t's were just sort of a formula sheet, so here I call it x, so I'll just continue with that. So what we're going to do here is we have 1 over 40, okay? I'm going to integrate it shortly, but just bear with me for a second. I'm just going to sort of separate out 1 over 40 into 1 over 4 times 1 over 10, okay? So you see what I'm doing here? I'm taking the 1 over 4 out, okay? Didn't mean to do that. 1 over 4 goes outside and it's constant, but the 1 over 10 stays in, okay? And the reason is I can use that result directly there, okay? So I have 1 over 4, should be a minus actually, minus 1 over 4, minus 1 over 4 times e to the minus x over 10, okay? And likewise, the second component was 1 over 20, so I'm going to express that as 1 over 20 as 3 over 60, and I'm going to split that up again as 3 over 4 times 1 over 15, okay? And again, I have the minus sign out here. Sorry, I dropped the minus sign there. So minus 3 over 4 to the power of e to the minus x over 15. Okay, so those are the two component parts. Okay, so what I'm going to do there, yeah, so I have the minus signs back in there properly. Okay, so that's all's well, all's back in order. Just forgot to check the last page. So when I evaluate that integral from 0 to infinity, so when I evaluate it at infinity, x equal to infinity, e to the minus x, e to the minus infinity just becomes 0. Okay? So that just sort of cancels out. When I evaluate e to the power of minus x divided by 10, when x is equal to 0, that just becomes 1. Okay? Just be very quick with those sort of things as well. E to the minus infinity is assumed to be 0, and e to the minus 0 is 1. E to the minus 0 is a tautology really, but so it's e to the 0. So, and we have a minus sign there. So we end up with 0 minus minus 1. So overall, the expected value there is 1. Okay, so again, this sort of stuff here, just be ready for those things again. Okay? Now, the second moment. Now, this is going to require, using previously mentioned identities, which I sort of used at the start of this video, and integration by parts. We could show that the expected value, the integral of x times e to the minus x over a dx is as follows. Okay? And when we evaluate that from 0 to infinity, we can state that as a squared. Okay? So x times e the minus x over a dx. When we integrate that from 0 to infinity, we work it out. It should work out to be a squared. Okay? Now, I'm not going to evaluate it, partly because I've done it in another video, and I just want to keep this video short, but just actually it's an important identity, and just be ready to sort of demonstrate it there, because, it's just a few extra lines and you have the job done, You're good. So it should be quick enough. It's actually the hard work for this sort of question. Okay? Just demonstrating that, because it probably won't be given to you. You probably won't be able to sort of just use it as a sort of self-evident axiom of integration, the way that you could get away with the other ones. This one probably has to be demonstrated in your exam paper. So just be prepared to do a bit of integration by parts to sort of work it out. Okay? Now I'm going to move on from that. So something I'm going to do very similar to the last time around is we have 2x. So yeah, we're going to sort of calculate e to the x squared. Okay, and I'm going to split it up into two parts. So it's 2x times the survival function, which I've sort of split up into two. 2 times x times 1 over 40 times e to the minus x over 10. Okay, so we have 2 times 2x over 40 is 1 over 20. Okay, now just actually you notice in this instance I'm bringing the entire fraction out. Okay, there's nothing left in here anymore. It's x times e to the minus x over 10. Okay, there's just something slightly different there. Okay, that's x times e to the minus x over a. Just actually watch out for that, because I don't have a coefficient in there like I do previously. Alright. So that ends up as, using that identity, we can state this directly as 10 squared. So 1 over 20 times 10 squared is 100 divided by 20. That's equal to 5. Okay, same thing here. So I was checking I have everything right. 2x divided by 2x times 1 over 20 times e to the minus x over 15. Okay, now we don't have to do any tricks, really. Do we? No, we don't. So that was actually not really necessary. So it's 1 over 10. You can disregard that. I forgot that I didn't really need it. 1 over 10, which is 2x over 20, or 2 over 20, times the integral from 0 to infinity of x times e to the minus x over 15 dx. And again, that's 15 squared. which is 225. 225 divided by 10, that is 22.5. So the expected value of x squared is 5 plus 22.5, which is 27.5. Okay? Now, don't forget this last part here. Variance is the expected value of x squared, 27.5, minus the expected value to be squared, minus 1 squared. 27.5 minus 1, that gives us 26.5. So that's the answer we're looking for. That is the mean and the variance. So let's just check what the hard part was. Just this part really. Be really ready to get going on that. Okay? Just sort of have it ready, ready to go. You know, just state it out as a little proof in your exam paper that you should get a squared, because when you get a squared, okay, perfect. You just have to pick out a from your formula and then say, oh, that's a squared when we integrate it. Perfect. And what else do we have to remember? Yeah, that's all basic stuff, and you should know it, and you won't be forgiven for not knowing it. Okay? And yeah, of course, these as well. Okay. So, leave it there.